Welcome to this special bonus episode of the Passive House podcast. I'm Zach Semke, Director of Passive House Accelerator, and we're pleased to be sharing a series of bonus episodes recorded at PhiusCon 2022 in Chicago. These interviews were made possible by generous support from Corp and Zola Windows. In this interview, Passive House podcast co-host Matthew Cutler-Welsh speaks with Ryan Abendroth of Passive Energy Designs and Stefan Goebel of Passive House Houston. Enjoy.
So I'm joined by Stefan and Ryan. Thank you for joining us. Ryan, give us a bit of a background as to who you are and what you do.
Sure. My name's Ryan Abendroth. I'm a certified Passive House consultant living in St. Louis, Missouri. Got my start in Passive House in 2009 as a student building a solar decathlon competition house at the University of Illinois.
I love the solar decathlon.
Yeah, so we transported the house to Washington, D.C. And competed, and there were two Passive Houses there, the German team and our team from Illinois.
Which is kind of, because Passive House seems like an obvious solution to that challenge.
Yeah, but it was just early on, right, in 2009.
Right.
So,
right. Sure.
But the German team happened to get first place, and we got second place.
Wow.
So I thought two Passive
Go
Houses,
Passive House.
Then, working really well.
We should probably describe the solar decathlon for people that aren't familiar with it.
Sure, it's a student competition that up until recently, students would design and build houses that were able to be transported to a competition site.
Yep.
But now the competition has changed, and you can actually build in your own hometown.
Right.
So the transportation is not a factor necessarily.
Right.
So I think that actually lends itself to some different building techniques and.
And what's the decathlon part of it?
It's part of the U.S. Department of Energy program. NREL, National Renewable Energy Lab, sort of helps organize it, or originally helped organize it. There's been some different organizers over the years. Another really kind of cool thing about it now, though, is they have a design component. So they've put a design competition and a build competition together. So there are a lot more involvement of students around the country learning about these types of techniques that are, just getting into it and don't have to have the financial wherewithal to actually build the project to start learning.
But you have to do a whole series of challenges.
Yeah, so the
competition.
decathlon means there's 10 competitions.
Yeah.
And so, there's subjective ones like architecture or engineering or things, right? Yeah, what's it look like?
Yeah.
And then there's objective ones where they're actually measuring you doing laundry or cooking or, throughout the years. The competition has changed, like what the emphasis is. So sometimes market viability has been big, other times it's been usability or net overproduction of PV or whatever. It's just evolved,
And now you're professor?
Yep. So I'm a senior lecturer at Washington University in St. Louis, where I teach design studios and some seminars, some related to Passive House, some related to just general kind of architecture and design. Like this semester, I'm teaching a graduate studio for incoming students. Mm-hmm. So it is more basic in terms of design overall and less specific to Passive House.
Passive House not in the curriculum? You try and sneak it in there?
Yeah. We work with, the way we've designed our curriculum is to have different emphasis throughout different semesters.
Right.
And so part of this is usefulness, functionality, and environment are kind of some of the key terms that we're trying to get in this first semester.
Yeah.
But it's not necessarily, Passive House.
And Stefan, what about yourself? Give us a quick rundown of how you get to be here today.
Yeah, I'm Stefan Goebel. I'm native German. I moved to the United States 7 years ago. Started off in Boston, where I was the general manager of a German architectural glass firm, and through that became involved in high-performance buildings. They had some very sustainable products. One of them, for instance, a bird-friendly glass, very, very niche market, but highly sustainable.
Bird-friendly?
Bird-friendly, yeah.
What does that mean?
So essentially, it's a product that mitigates birds from colliding with glass. There's estimated 1 billion birds per year that collide with glass.
1 billion?
Yeah, it's about 10% of the bird population, so it's a big issue. And that company came up with a product that mitigates bird collisions, but also maintains transparency for the human eye, because they're not putting up dots or bird stickers or sort of that. So in that sense, they had some other high-performance coding products. So I was working with architects on lead projects, passive house projects, and consulting them. So it got me really interested in the high-performance building industry. And in 2017, I went through the CPHC training, and Ryan was actually the trainer in Boston.
Yeah.
And got very passionate about it, and started working on projects, and even taught an elective on construction technology and passive design at the City College in New York. But then after about 3 years, my wife got an opportunity to work at NASA in Texas, so
nice.
Houston, Texas, and I had to move to Houston, Texas, and I had never been there. Had no idea what it was about. Thought about cowboys riding in the desert and shooting guns. So what can go wrong?
Yeah.
But I was very wrong. So also talking a little bit about Houston and the PhiusCon 2023. Houston is an extraordinary place. It's sort of similar to my hometown Cologne, a little bit rough around the edges, but the people warm, welcoming, inviting. It's just a great place, especially to be around this time of the year. And considering the building growth, the South is really on fire. We're looking at, for instance, September single house permits. 60% of the entire United States single residents that were permitted are in the South. So
the South being defined as
Texas,
southern
states. Yes, southern states.
Wow, so mass migration south. Mm-hmm. Pretty different climate than where were you before?
Very different. So I was in Boston, and I'm from Germany, so I'm used to a cold climate. Now we're in a hot and humid climate. Yeah. Although the winters can get cold, so it gets down to 30.
And it snowed there this year.
Last year we had a freeze. I think that was an awakening for many, many people.
Yeah.
There is, I think, 1,600. It's actually 1,600 heating degree days and 2,600 cooling degree days. So it's fairly cold in the winter, and then in the summer it's brutally hot and humid. Yeah.
Is there a certain amount of irony that you were taught Passive House as a German by an American in America?
I like that. Yes, especially as an enclosure consultant, we tend to think that we're 15 years ahead of the United States.
But in some ways you are. I mean, in a lot of ways
we are. Yeah. But being trained by somebody like Ryan, who's just one of the experts in the U.S. on Passive House, I'm very honored that I can work with him and learn from him.
Yeah. Yeah. Because, I mean, just staying on that at the moment, I mean, the building code in Germany is pretty close to Passive House.
It is.
And getting closer all the time. And is it also fairly uniform, or is it quite regional?
No,
in
it's
different states.
Uniform.
Right. Whereas here in the States, I mean, how many different jurisdictions of building code are there? Do you even know?
No one would know. But when we talk about Houston in our projects, we're actually looking at insulation levels that are pretty much code.
Right.
We did a whole presentation about...
In order to achieve Passive House?
Yeah, Passive House at R40 in the roof, which R38...
I don't know what that means.
R38's current code.
You have to convert that to metric for me.
It's for him to do.
You're the professor.
Well, something a little simpler is the windows. We get away with double pane windows in the South, so you're really cutting costs there.
Yeah.
And building a Passive House in the South, to me, seems a lot more feasible and cost-effective.
I mean, we have a similar situation in Australia and New Zealand where you can get to a Passive House level of performance in, say, Auckland with a 90 mil stud. It's a sort of 4-inch standard stud. You might have to do a little bit of extra with air tightness and ideally getting rid of some of the thermal bridging, but because the climate is relatively mild, it's not a massive drift. Coming back to the R value, I think it's around about Zach and I think we said it's divided by 5. So you said R 40. So that's pretty high. That's like an R8, I think, in metric terms ish. 6, 8.
I mean, the way to think about it is it's a 2x6 wood stud with 1 inch of, well, if we're talking about the roof, it might be more.
So lots of really interesting stuff happening. So how have you guys worked together most recently?
So we have 2 projects that we're working on in Houston. One is for Positive Impact Homes. It's by a veteran who has PTSD and a special needs child. So they're really trying to build a prototype home that they can use more than or just beyond what they're doing on their local site.
Right.
So it's a really cool single family type project. Mm-hmm. And then we have another project in Houston that's a duplex with also 2 sort of one studio apartment or like Airbnb type units attached to it as well.
And are they just going to be one-off projects?
Yes, but kind of like I was saying with Positive Impact, they want to be able to use what they're learning to build more veterans housing.
Yeah.
And the other project, the client is actually a developer.
Right.
So it's going to be a personal residence for him as part of that. But he's looking at using it on much larger projects.
Right. Yeah. Let's talk about Texas, warm climates. How well does Passive House work down there?
Well, we have 3 passive houses that are certified now. There's 2 in the sort of design. There's 2 of the design certified. So I think we yet have to see how well they perform there. But I would expect that they perform fairly well. Considering that the construction itself is very close to what code minimum is. Of course, we need an energy recovery ventilator, which is not common in the South. So I can't answer that yet.
Were there any challenges to getting certified?
Both projects are that we're working on, they're not certified yet. So we're in permit, and there's definitely some challenges that we went through. So for instance, the underslab installation or the bridge design on one of the projects, which maybe Ryan, you can talk a little bit about.
Yeah, so I think there's 2 points there. One, there is going to be in some of these new climates things that we have to look at a little more in depth just to see how they work.
Yeah.
And one thing is we are actually removing all the sub-slab insulation on the projects for slab-on-grade projects. And that's a lot different than almost everywhere else in the U.S.
Are you keeping insulation on the edge of the slab?
We have modeled it on the edge and without, and what I was worried about was a temperature difference at the corner. But adding a whole lot like this month, big amount of exterior insulation there on that slab edge only really increased the temperature by a couple degrees in the interior corner of that floor assembly. So it would be nice to get an inch or 2 of insulation there.
And are you looking at that from a total heat loss point of view, or is it a thermal bridge issue and a condensation issue?
Yeah, both. So the total heat loss point of view is very, very minimal.
Yeah,
it's more the condensation risk or comfort. Around that colder edge in the winter.
So your modeling is showing you that it's not a massive problem,
right? Yeah.
And does that allow you to comply with the Phius standard?
It does. Yeah.
Right. So going back to my question about certification. From a design perspective, it's ticking all the boxes and it's looking okay.
Yeah. No, we're meeting all the boxes, and there are advantages in terms of solar insulation and being able to provide renewable energy with the amount of sun and different things that a lot different than up in north parts of the U.S.
What about overheating?
That's always my concern. Mm-hmm. Even I work in a lot of projects in Kansas City, St. Louis, lower Midwest. that localized overheating in a given room, usually on the southwest corner,
Yeah.
when the kid comes home from school and they plug the Xbox in
Yeah.
and 3 friends, that's always a
Working on
big
some internal
issue.
loads
Yeah.
there as well.
Right, and so having a single ductless mini split point source cooling somewhere in the building is not going to be enough to make sure that that specific space is comfortable. So it's really about, I think, distribution of the cooling to where you need it, when, and it comes down to systems design.
And then, of course, shading northwest, east.
And glazing specification?
Glazing specifications. So the solar heat gain coefficient is comparing Houston is 0.25 compared to New York City 0.40.
Yep.
So there's a big difference. And then making sure that we have that low solar heat gain coefficient. So using that low E coating in the glazing, shading the west, the north, the east, the south in the summer.
But are you putting the low E layer on a different layer than you might further north?
They're typically on surface 2 on an insulated glass unit, and that is fine because that's as far on the outside as we want to be.
Right.
As long as, if we were to work with hard coats, but I'd like to go away from hard coats and using soft coats on surface 2 to reflect that solar radiation. Yeah.
We just went pretty deep on some jargon. Let's break that down a little bit. So, soft versus hard. What does that?
Well, I think soft coats gives you a lot more flexibility because essentially with soft coat, you have a flat glass that's manufactured, and then that's cut to size and that's sent to decentralized manufacturing plants that can then add the magneton sputter coatings. And that gives you a lot more flexibility in what kind of product you can use in your project versus hard coats or they tend to be put on in an early stage during the flat glass manufacturing process.
Right.
And they also tend to just have a lot, their light to solar ratios are not quite as well. So for your visible light that you get in the light to solar ratio is essentially not as good.
Right.
So we can dive a little deeper on this.
We could. I want to make sure we're taking our listeners along for the ride as well. Solar heat gain coefficients. It's a great name. Do architects know what you're talking about when you start talking about those here?
Yes, for sure. Teaching students, they may not, but architects know what solar heat gain coefficients are.
Why is that?
Why the students might not know?
What do is it something that architects have to be aware of because of
yes, they have to be aware of it. The glass really is the weakest material in the envelope.
Yeah, it's a hole in the wall.
It's a hole in the wall, and the solar heat gain is an issue. And knowing that percentage of the solar radiation that hits the glass that goes to the interior is important because we need to know what the cooling loads will be besides I mentioned the mechanical systems.
Are architects getting used to the idea of potentially specifying different glazing around different aspects of the same?
I think that's a fantastic point. We have to do a lot more. We have to educate the architecture community that is possible, that we use a low solar heat gain coefficient on the southeast orientation, and then working with perhaps a different coating that's color neutral, similar, with a very high solar heat gain coefficient, so that we can get more visible light into the building where we really don't have much heat gain happening.
So, but the main point is that you don't have to do the same window suite across the whole building, but optimizing it for direction and possibly for sight as well.
Absolutely.
If there's a particularly nice view that in a not ideal thermal location.
Yes.
And what about? Did you have to play around with external shading for your modelling for this region?
Yeah, I mean that's one of the best things that you can do, but it's not always feasible in every project. Also, to do it cost effectively.
Yeah.
The good thing about a climate like Houston that's predominantly cooling is the winter you still don't need a huge amount of solar gain to make your heating numbers work.
Yep.
So and the one project, there's a pretty good porch on the front with a long overhang, 4, 5, 6 feet.
Yeah.
And on the back it's even larger. So kind of all around this house there's really deep overhangs. and use them as outdoor living space to get that, really good external shading without worrying about movable shades or things that need to allow in a colder climate would need to kind of be ideally moved or at least allow sunlight in the winter.
So you want to avoid moving parts or relying on user interaction. So I don't know much about Phius because I'm in sort of PHI world in Australia and New Zealand. How's forgiving, or how well does Phius work in a warm environment? So the allowance at the moment is sort of 10% exceedance of 25 degrees Celsius under PHI. How does it work for Phius? What are the criteria for the particular building that you're working on?
Yeah, so it works really well because there's so much climate-specific information that has occurred over the last 7 years. Since 2015 is when Phius put their first climate-specific standard out.
Right.
And since then, that's been refined. And so, to put it into metric terms, I think it's right now, let's say, it's like 50 or 60 kilowatt hours per meter squared is the cooling demand load. So it's quite a bit higher compared to 15 kilowatt hours per meter squared, right?
Thank you.
Yeah.
Appreciate that. What is that for you? What numbers do you use?
So I think in Houston we were at like 17 something kBTUs per square foot. Of envelope area, where the standard is 4.75 if we were looking historically back where Passive House started.
Yep. And some variants for building type and building size as well.
Right. So that's the thing where I'm having to sort of ballpark it for you because the envelope size to floor area size, that ratio, the amount of occupants, the specific climate location, whether we're in Houston or out of town a little bit, there might be another data set that we can use. All of that factors into what the criteria that specific building has to meet. So it's very building specific. And therefore, it's working out really well in terms of the modeling. Because it is so specific.
Interesting, coming back to the floor slab, talking to someone who just completed a passive house in Sydney, I think, or could have been Cameron, somewhere in Australia, and they found the same thing with their modelling, where it actually performed better in a warm environment without under slab insulation because it allowed the slab to cool down. Basically, that connection to the ground was useful rather than detrimental.
Right, and there's one other point to make there is actually the modeling is showing that a very slight amount of insulation might be better, but it's better in terms of 100 or so kilowatt hours per year on the whole project. And then when you look at the amount of energy in a piece of foam, for example, to do that, and then the time, source, costing, etc., you could put half of a PV panel on the roof and come out ahead compared to insulating the slab.
Yeah, that's a good point about using the software wisely to make judgment calls that are going to be the best overall solution rather than just individually optimizing every single element because it might not be the best overall solution.
And we saw as a side note that the cooling energy can go down by half whether you're insulating the slab or not. It's a really bit on. These are longer, ranch homes, one story, so they're getting a lot of ground contact. Right. But it's a dramatic potential difference.
And it's important to note that because if we had followed the prescriptive path, it would have asked for an R8, I believe, under slab. So doing the modeling really showed us that.
Well, and the other aspect is the area to volume ratio. It kind of disrupts that idea that small and compact is always best. It says, well, you still got to pay attention to that, but it may not always be the optimum.
That's the sort of secret or dirty secret or trade-off of the Phius way of doing things is they made this standard completely scalable for skyscrapers to large multifamily to single family to tiny homes. And to do that, it must expand and contract with different volumes and areas and things and ratios. And because of that, compactness is not really that important to meeting the standard, because if it's less compact, the standard stretches to allow you to use a little more energy. So it is sort of a downside, and that was actually my 2019 PhiusCon presentation was on that exact topic.
Yeah. Is that an ongoing discussion point?
Yep. I just think there's always trade-offs on every system.
Yeah.
Right?
Yeah.
You solve for a few things, like they've definitely solved for problems that were existing in previous versions. But by doing that, then they create other trade-offs.
Yeah. You're not just a professor at university. You've been doing some teaching here as well. You're involved with Phius.
Yep. So in 2009, with that solar decathlon project, I met Katrine Klingenberg and started working that summer at Phius in the Phius office. And I was a certification manager for 4 years.
Yeah.
And then because of that, I started training. So I've been teaching certified passive house consultant training courses, therm courses, all kinds of things for Phius since about 2010. Earlier in this conference, I was teaching the advanced multifamily WWOOFy course for Phius.
I would imagine they're probably some of the hardest things to teach.
Yeah.
Therm and WWOOFy.
Therm is, we're getting it down, right? We have a curriculum now, and it's really going. But a decade ago, it was almost impossible. But we've had some experience on how to do it, and I think that helps. Yeah. But these advanced courses that Phius are teaching are really nice because the set curriculum is very small. Right. So it's about having these sorts of discussions about how you would treat certain things in buildings, what the model's showing, specific things, and really talking through problems and issues and different resources to address those.
Yeah. So what's next for you guys? You're leading up to, we talked about 2023 briefly. So just to clarify, that's the site of next year's Phius conference, that's exciting because that's kind of Phius Passive House heading to warm climates.
Yeah, and I guess our next step is getting these couple of passive houses built and working on a few more.
Get them ready to show off for next year. We'll be expecting a site tour.
Yep.
It would be great to catch up again and check on that progress. But beyond that, where would you like to see things? I'll ask you both individually, starting with you. Where would you like to see in the next 5 years Passive House in America?
I think it's about getting the system simple and very used to what builders and occupants and everyone are used to seeing. Yep. So trying to use very straightforward systems. That's why I like these projects in Houston, because they're very close to, we can do it in a way that's very close to what's being built. Yep. Therefore, it allows it to scale. Yep. That's the thing. Yep. And if we keep reinventing these new wall systems that are really special and we use them on one-off time, we're not going to get to where we need to go. So I'm trying to
making the complicated
simple, cost-effective building enclosures that are really easy to implement in the field is what I'm looking to try to make happen.
What about you, Stefan?
I think we have a lot of work to do in the built industry on an operational, but also on an embodied carbon topic. And I think looking at the next 5 years, the embodied carbon, I think, is going to be more important, and touching on what Ryan said, having simple solutions, efficient, simple solutions that can be built by local companies so that we don't have to ship material around the world to execute these projects, and that the trades feel comfortable in executing those projects. I see that for the next 5 years as an important point.
Yep. And is Passive House a good way to do that?
Yes, and particularly due to the climate-specific standard it is, I think.
Yeah.
So it allows you to use less insulation material in cells where you don't really need it.
Absolutely. Where can people find you guys and follow what you're up to? Either of you? What about the houses that you're working on at the moment? Can people check progress on those?
Will be soon, yeah.
Right.
But I have a website, passiveenergydesigns.com, where you can find me and find my contact information.
Great.
Same here, Ecotech Consulting-us.com, and then Stefan Goebel on LinkedIn.
Nice. Thank you both. Great to chat.
Thank you.
Thank you.